Hi everyone. In this video we will discuss about cluster compounds. And after the introduction portion we'll see how to calculate the number of metal-metal bonds using 18 electron rule. So moving on to our topic. If you are given with a compound which have many metal atoms, then there is a possibility of bond between those metal atoms, not between the metal and ligand, but there is a possibility of bond between one metal and another metal. Such compounds are known as metal clusters. One such example for metal cluster compound is metal carbonyl clusters. So we can divide this metal carbonyl cluster to two categories. One is low nuclearity carbonyl clusters it is also known as LNCC, low nuclearity carbonyl clusters, and the other one is known as HNCC or high nuclearity carbonyl clusters. Here we will discuss how to calculate a metal-metal bond between a metal carbonyl cluster using the 18 electron rule. In our next video we will discuss about how to calculate the metal-metal bond by using 16 electron rule. So here I have written the steps which you have to follow when you are calculating the number of metal-metal bonds using 18 electron rule for these metal cluster compounds. And here we will be discussing metal carbonyl clusters. That means here your ligand will be carbonyl ligand. So move on to the steps. So firstly what you have to do is, if you are given with a compound, so first you have to calculate the total number of valence electrons or total valence electrons on the central metal atom in the compound. So when you are calculating the total valence electron, what you have to do is you have to add up the number of valence electrons of the metal plus the number of electrons from each ligand and the charge. So valence electrons of the metal means you have to add the last shell electron, how many electrons are there. Then you have to add the number of electrons contributed by the ligand. Here we are discussing about the carbonyl ligand. Each carbonyl ligand will be giving 2 number. So that is done. Then what you have to do is, if any charge is present in the complex which is given to you, then you have to add that charge also. So you will be getting value. Let that value be A. So if you are getting it as 36 or 38, that value is your A. Then what you have to do is, now you got that A. So you have to subtract that value which you got from this first step from n into 18. That means n here is the number of metal atoms present in the compound. If imagine the compound which is given to you is Mn twice CO 10 times, like Mn twice CO 10 times. If this is the compound given to you, here you have 2 metal atoms. So in this compound your n will be 2. So then you have to multiply 2 into 18. Then you have to subtract A which you got from the first step from this value. So you will be getting a value, name it as B. Here I have written the step. B means n into 18 minus A. That means the value you are getting from the first step by calculating total valence electrons. Then in the last step or the third step, what you have to do is you have to divide the value which you got in the second step by 2. So you will be getting a number that will be the total number of metal-metal bonds present in your compound. And here on the first step you got one number, that A. When you are dividing that A with the total number of metal present in your compound, then you will be getting total number of electrons per which is contributed by the metal atom. So when you are calculating for different examples, the idea will be much more clearer. So moving on to the examples, let's consider the first example as this compound itself, Mn twice CO 10 times. So what according to our steps which I have shown you previously, first you have to calculate total valence electron. That means let's keep that value as A. So how you have to calculate the total valence electron? Here you have two metal atoms. So 2 into the valence shell electronic configuration of this Mn, it is 7. So you know how to calculate. School teaches very cruel Mn. Mn in the +2 oxidation state, it is having 5 electrons. Here there is no charge for the complex, so it is 5 plus 2, that means 7. So 2 because 2 metal are there. Then Mn because Mn comes here 7 because of the valence shell electrons. Then 2 into 7 plus. Here you have CO ligand. 10 CO ligand you have, and each CO will be giving 2 electrons. So you have to multiply 10 with 2. Because there is no charge for the complex, you just have to add up everything. So 14 plus 20, that means 34. So here your total valence electron is 34. Then you have to come to the second step. In the second step you are calculating B. What is this B? B means N into 18 minus A, that was the equation I have given. N means number of metals. Here in this compound you are having 2 metal. So 2 you have to multiply with 18. Then you have to subtract your A. A here is 34. That means 36 minus 34 is equal to 2. Then what you have to do is B divided by 2, that is your total metal bonds. So B divided by 2 means 2 divided by 2, because your B is 2. So 2 divided by 2, that is equal to 1. So in the given compound Mn twice CO 10 times, you have one metal bond. Then to calculate the number of electrons per metal atom, what you have to do is A divided by N. A divided by N means A is 34 and N means total number of metal atoms. Total number of metal atoms in this compound is 2. So 34 divided by 2, that will be giving you 17 electron. So this is not a 17 electron complex, because in your compound there is a metal bond, one electron is being consumed in that. So here comes 17, and this 17 is a clear cut indication for one electron is being used by the metal bond. So moving on to our second example, consider the example of CO twice CO 8. This will be our second example. In this compound, upon calculation, what you have to do is, according to our steps, first you have to calculate the total number of valence electrons, A, that is equal to, here CO, cobalt is 2 cobalt atoms you have. So 2 multiplied with the number of electrons provided by the cobalt is, school teaches very cruel, Monet FeCO. CO means in +2 state you have 7. So here you don't have any charge. So it will be 9. Plus you have 8 carbonyl ligand, and each carbonyl ligand will be providing 2 electrons. So 8 multiplied with 2. Because there is no charge, you don't have to add any charge. So this will be 34. Then you have to calculate your B. The equation for B is N multiplied by 18 minus A. That is, N means number of metal atoms. So here 2 metal is there. 2 into 18 minus 34. So again you will be getting the same value as the previous example, it is 2. So then you have to do is B divided by 2 to find how many metal bond is there. So 2 divided by 2, that is equal to 1. So in this case also you have one metal bond. Now to calculate the number of electrons contributed per metal atom, present per metal atom, you have to divide A with N. Here A is 34, that means 34 divided by N means number of metal atom present in the compound. So 34 divided by 2, that is again 17. So you can confirm that your this compound is also having one metal bond. But there is a speciality for this compound, or you can say this compound is little bit special. So this will be more favorable for the examiner to have this question in exams. That means the importance is this compound is having a different kind of structure in solution and in solid state. That structure I'll draw here. If you're taking that compound in the solid format, that compound will be having a structure like this. This is your metal, and here is your the second metal. Then carbonyl ligand. Again here you will be having a carbonyl ligand. So this will be the structure of we are discussing. The structure of this compound. So in solid state you will be having a structure like this. So you can here you can see 2 carbonyl ligands are bridging between the 2 cobalt metal. So you can say that mu2CO twice cobalt atom twice and 6CO are terminal ligands. So you can name this structure in solid state as this one. Here hapticity of 2 cobalt atom is 2. Then in case of if we are dissolving this compound in hexane medium, what you will be getting is the structure will be converted to 2 metal atoms will be there. Then all carbonyl atoms will be terminal one. There won't be any bridging between the ligands. That's what is being observed. So this will be your structure in solution. We'll take one more example. Let's take the example of Fe twice CO9. So in this case, again first you have to calculate total valence electrons, because 2 metals are present. Here you have to multiply 2, and Fe means it will be giving 8 electrons. Then you have 9 carbonyl ligands. Each ligand will be giving 2 electrons. So 9 into 2. That means again the same number 34 you will be getting. Then you have to calculate B. B means N into 18 minus A. A means the value you obtain here. That is, here 2 atom is there. So 2 multiplied by 18 minus 34. So you will be again getting 2. B divided by 2 is your metal bonds. So 2 divided by 2, again 1 metal bond is present. So A divided by N is total electron count. So number of metal bonds bonds per metal will be 1. That means 34 divided by 2, that is equal to 17. So 17 electrons, but this is an 18 electron complex, so 1 electron is being lost in between this metal bond. So this is about the Fe2CO9 example. Then let's take another example. Let's take a little bit different example of another Fe complex, fourth one. Yes, I'm writing it here. Fe3CO12. In this case, when you are calculating the total valence electrons, here you have 3 metal atom, and Fe will be giving you 8 valence electrons plus 12 ligands you have here. So 12 multiplied with carbonyl ligands means 2 electrons it will be giving. So whole together you will be getting 48 valence electrons. Then when you are calculating B is given by the formula N minus 18, N multiplied by 18 minus A. That means here you have 3 metals, so your N will be 3 multiplied by 18. Subtract the value of 48 which you got in the above step, minus 48. So here you will be getting here this will be 6. So what you have to do is, now you have B, you have to calculate B divided by 2, that means 6 divided by 2, that means 3. So total number of metal bonds will be 3. So in this compound there will be 3 metal bonds, and A divided by N will be giving you a total number of electrons per metal atom. So that will be 48 divided by 3, that is equal to 16. So you can say number of Fe bonds per Fe atom is 2. So from one Fe atom there will be 2 bonds. So the structure of this compound is little bit complicated. I'll write here the structure of this compound, Fe3CO12. So structure of this compound will be, you have 3 Fe atoms, so I'm writing it in the form of a triangle. Then as from your calculations, you know 2 bonds will be there for one Fe atom, metal bonds. So one metal bond and the other metal bond. So that is complete. Then you have to fill with your ligands. Then here also 3 carbonyl ligands will be there. Again 3 carbonyl ligands will be there. Then I'll draw the rest carbonyl ligands as the bridging one. So this will be having mu2CO twice, because 2 carbonyl ligands are being bridged between these 2 Fe atoms. Then you have Fe3 and 10 carbonyl ligands in the rest portion. So here you have to draw one more again. So this will be the structure of Fe3CO12. Now another example we'll consider. Let's take a simple example of, let's consider a general example, M2CO9. I don't remember the number exactly. So M2CO9 will be your complex, the general formula of your complex, and the metal can be Ru or Os. So when you are calculating the total valence electron of this compound, you have to calculate if any of the complex means it will be giving of these elements means it will be giving 8 number of electrons, because this is coming under the Fe. So 8 will be there and 2 metals are there, so 8 into 2. Then you have to add 9 carbonyl ligand is there, and 1 carbonyl ligand will be giving you 2 electrons and there is no charge. So when you are adding up, you will be getting again 34. Then you have to calculate B using a formula N multiplied by 18 minus A. That means 2 multiplied by 18 minus 34, it's again 2. So B divided by 2, that means 2, this one divided by 2. So you'll be getting 1 metal bond. Then A divided by N. When you're calculating, that is 34 divided by N, that is here it is 2. So you'll be getting 17. So number of metal bonds which is present per metal atom, that is 1. So according to this calculation, structure of these kind of complexes will be, here you have to fix your metal and you have to draw the carbonyl ligands, and 1 CO will be bridging in this case. CO. So this will be the structure of this general compound. So like this you can calculate the number of metal bonds present in a compound using 18 electron rule. In the next video we will discuss about the same calculation using 16 electron rule. Thank you.